Hi again, everybody. Welcome to our second video on trigonometric integrals. In the first video, we used the so-called Pythagorean identity, namely that sine squared plus cosine squared equals 1, in order to rearrange an integrand of a trigonometric integral, making it easier to solve. In this video, we're going to modify this formula to give us a new trigonometric identity that's going to let us solve, well, another trigonometric integral. So what are we going to do? Well, I'm going to take this equation and I'm going to divide everything by the square of the cosine function. So term by term, divide by the cosine squared. And if I do that, I see, well, here I have sine squared over cosine squared. Now sine over cosine is tangent. So this becomes tangent squared plus, well, cosine squared over cosine squared, that's just 1. And that equals 1 over cosine squared. Now since 1 over cosine is secant, this becomes secant squared. So this is an alternate version of the so-called Pythagorean identity, only this one relates the tangent and the secant functions. How do we use that for solving integrals? Well, let's try one. Say we wanted, instead of cosine cubed, say we wanted to find an antiderivative for the tangent cubed. Well, I play the same game as I did with cosine cubed. I'm going to rewrite this tangent cubed as tangent of x times tangent squared x. Why? Because I want to use this formula here. Right? Now, if tangent squared plus 1 is secant squared, then I can rewrite tangent squared as secant squared minus 1. Okay, so we'll rewrite this bit. The tangent squared, this becomes secant squared minus 1. And now I can rewrite my antiderivative as two different ones. First, tangent times secant squared minus, now another one, this will just be tangent times 1. Okay, this is an antiderivative of the tangent function. All right, so here I see I have a function tangent and its derivative secant squared. That tells me I can do a really easy u substitution. Right? So I would use here u equals tangent of x, and then secant squared dx is my du. Hey, that's not too shabby. I can integrate that. Antiderivative of u is u squared over 2. So I get tangent squared over 2 minus, and now I need my antiderivative of tangent, which looks difficult until you remember tangent is sine over cosine, which again, I have a function cosine and, well, almost its derivative, sine. And so I can actually use another u substitution. I'll let that be my u. And then, well, if I put a negative in front, then I get my negative sign. And now this negative sign with the dx becomes my du. All right, so I end up with du over u. So I'll get ln of the absolute value of u, and this becomes plus natural log absolute value. What was my u? Right, it was cosine of x. And then, of course, we add our constant of integration. Okay, so there's a few little substitutions in here. That's not too bad to work out. But the important thing is from the beginning, it really wasn't clear how to handle a cube of a tangent function. But using this trigonometric identity, we quickly were able to break it up into two much simpler integrals.